Hello everyone and welcome back to exercise number 40 of the SolidWorks basic tutorial series. In this video, we're going to be designing a slotted conical mount. As always, in designing this part within SolidWorks, we're going to be using many of the SolidWorks features, namely the extruded boss base feature and extruded cut feature, but also in creating the main body of the component, we're also going to be using the revolve boss base tool. Here we see the schematic drawing for exercise number 40. We have the isometric view, the front view, the section view, and this section view was taken along this horizontal line here, right? Now, the presence of this top view here, again, we haven't defined or we haven't put any dimensions here, but it's only here just to showcase where exactly do we take the section view for this view right here, all right? So we have a number of instructions here. Number one, it says here to open your 3D CAD system. Again, these instructions are pretty self-explanatory and pretty obvious. Step 2 is to model the part using the dimensions shown, and step 3 is to assign a material of ASI 1020 steel. And we're going to assign a material in order to answer this question right here. That's in red. That reads, what is the mass of this part in grams? And we're only going to accept answers that within a tolerance of plus or minus 1 gram. All right. And at the end, we're going to calculate the mass of the component. Okay, so looking at the main features for the component here, we see that we have a conical body, right? And to create that within SolidWorks, I think the easiest way to do that is to utilize any symmetry that we have. And if we forget or ignore any of the important or other secondary features for the component, for example, you have the slot feature and you have this hole and counterbore feature. If we just ignore that for a second, we see that the component has radial symmetry, right? Along the radius for the component. So if we take the y-axis here as the line of symmetry, and then we use the line tool to basically sketch out half of the profile for the section view. We could very well use the revolve boss base tool to create the main body of the component, the main structure, right? After that, we're going to work on creating this hole here. So we're going to select the front plane, and the front plane basically will lie midway between the component, dividing it in half. And then we're going to draw a circle, fully defining its position as well as its diameter, and then use the extrude cut tool to basically cut the hole through both directions for the component. After that, we're going to work on creating the counterbore feature. And again, we have two ways of actually doing that. We could either use the standard method of drawing a circle on the top face and then using the extrude cut tool to create the cut depth. Again, we need to use the extrude cut tool twice in order to do that. Or more simply, we could just utilize the symmetry again along the y-axis, as I said previously, and then use the revolve cut tool to create the opening, the counterbore feature. And for that, we're going to have to sketch out half of the profile here of the opening and then use the revolve cut tool, right? Finally, we need to work on creating this slot here at the bottom. And for that, we just need to select the front plane. Again, as a reminder, I need to remind you that front plane in this case will lie midway between the component. And we're going to sketch out the 2D profile. As you can see here, we have all necessary dimensions. We have this slot here, this angle slot actually has an angle of 60 degrees and an overall height of 10 millimeters, right? And again, utilizing the symmetry for the component, we're only going to sketch out 1/2, use the mirror tool to create the other side, and then use the standard extrude boss base tool to basically cut out the slot all the way through the component in both directions. All right. So we can do this again to recap in approximately 4 main steps. Step number 1 is to create the main body of the component using the revolve boss base tool. Step number 2 is to create the circle here using the extrude cut tool. Step number 3 involves creating this counterbore feature using the revolve cut tool. And finally, step number 4 is to create the slot here at the bottom using the standard extrude cut operation. Okay, so this is a 4-step modeling procedure. Okay, so with that aside, let's get started with exercise number 40. Okay, so we start by creating a new SolidWorks part. We set the background to plain white, and we copy exercise number 40 into SolidWorks. Let's just make this image smaller here. And as I said previously, the easiest way to model this is to actually use the revolve boss base tool to create the main body for the component. So to do that, we need to first sketch out half of the section profile that we see here, right, using the line tool. And then we're going to use the revolve boss base tool to create the main body for the component. So to start, let's go ahead and select front plane, sketch. Let's drag this to the top here. And we're going to activate the line tool. To do that, press your right mouse button and then move your cursor to the left. All right, and starting from the origin here, sketch out the basic profile of the section view. Again, we're only going to work on half of it. All right, all the way to the bottom here, then we move to an inclined line all the way right here, and then close off the figure. All right, now we need to define this sketch using the dimensions shown. So to activate the Smart Dimension tool, click on your right mouse button again, and then move your cursor upwards to activate it, okay? And we can see here that the overall height of the component is 60 millimeters. And I'm going to start by defining the largest dimension, all right? So the distance between this top edge and this bottom edge should be 60 millimeters. And let's go ahead and convert this vertical line to a construction geometry. And I'm going to tell you the reason why we're doing this. Activate the Smart Dimension tool again. And this time, instead of just assigning half of the dimension for this top edge here, what we can actually do is select the distance between this edge, and then we just move the cursor to the left. And that will give us the overall distance, right? So in this case, it's 26 millimeters, as you can see right here. The diameter of this top part here should be 26 millimeters. And we're going to perform the same operation for this distance in this line. And this line again is going to be 32, as you can see here. And the distance, or the thickness here, or the diameter, should be 38 for this bottom cylinder. So the distance here should be 38. All right. And we have an overall width of the component of 70 millimeters. So the distance between this point all the way to the other side here, since it's symmetrical, should be 70 millimeters. All right. Now we need to assign the vertical distance for the component. So for example, the length of this edge right here, if we look at the drawing, it's 15 millimeters. So again, activate the Smart Dimension tool, and the length of this edge should be 15 millimeters. All right. The length of this bottom edge here should be 10 millimeters. And as you can see here from the figure, see, this should be 10. As for this edge, should be 5 millimeters. So the distance, or the length of this edge, should be 5 millimeters. Now by default, the distance between this point and this point should be 30 millimeters, since we've already defined the overall distance here, right? And we have lengths of 15 and 10 as 25, plus 5 is 30, and half of 60 is 30, so this other side should be 30 millimeters as well. Okay, so that fully defines the 2D profile, or at least half of the section view here, again, according to the dimensions shown. So now what we need to do is just convert this construction geometry again back to a solid line. Again, need this for the Revolve Boss Base tool. Let's select, or press S on your keyboard, select Revolve Boss Base. Here it's going to ask you for the axis of revolution. Again, we just select this vertical line. And you can see here that we have a preview of what the operation will create. And that pretty much is similar to the main body of the component, right? So go ahead and select OK. All right, so now we need to create the openings for the component. If we look at closely here, we have, at least in the isometric view, we can see that there's a hole here at the top, a drill hole that runs along the component. And then we have a counterbore feature that runs all the way down to the bottom, right? And most importantly, we have a slot opening at the bottom right here. So how are we going to do this? We're basically going to select the front plane and then select sketch. And first of all, we're going to start by creating this hole here at the top, right? So activate the circle tool by, again, clicking your right mouse button and then moving your cursor to the right. That will activate the circle tool. And just hover over the origin here and then move vertically upwards. That will ensure that whatever circle you draw will be directly overhead or aligned with the origin component. In this case, it's symmetrical. And then just draw a circle. And the circle here should have a diameter of 10 millimeters. All right. So just to make sure, activate the Smart Dimension tool. And you can see here that by default, it has a diameter of 10 millimeters. And this is according to the drawing here. See, we have a hole of 10 millimeters. Now, most importantly here, people usually ask is, how far away is this circle with respect to the bottom surface, or at least any one of these horizontal edges? And we have no information here, none of it's shown. So if that's the scenario, if that's the case, we need to assume, or actually we need to infer from the image here, from the schematic drawing, that this circle lies midway between the two top edges, this top edge and this bottom edge right here. So yeah, the distance, we activate the Smart Dimension tool, there's distance between the center of this point and this bottom edge, half of 15 is 7.5, right? 7.5. So now the sketch here is fully defined. Press S on your keyboard, extrude cut. This hole cuts all the way through the component on both sides, so go ahead and just right-click on your mouse and select through both directions. You can either right-click or you can just select the end condition right here within this dialog box on the left. So now press OK. All right, so that creates the opening for the component. Now we're going to work on creating this slot feature at the bottom. So select Front Plane, Sketch, and we're going to activate the line tool. So again, right-click on your mouse and move your cursor to the left. And we can see here that since we have symmetry with the component along the y-axis, it's sufficient that we only draw or sketch out half of the profile for the slot feature. So starting from the origin here, let's go ahead and draw the profile, right? All the way to the bottom here, and then close off the image, the figure. Okay, now activate the Smart Dimension tool, and the angle between this edge and this horizontal edge should be 60 millimeters. The distance, half of the distance here should be 10, so the distance or length of this edge should be 10 millimeters. And the height between this top edge and this bottom edge, so the distance between this top edge and bottom edge should be 10 millimeters. All right, convert this into a construction geometry. All right, this dividing line, this partitioning line right here. Since we're going to mirror these entities all the way to the other side, and this need to make sure that everything is defined. All right, so what do? We just select everything that we've just drawn and then select the Mirror Entities tool. And that will automatically create the mirrored entity on the other side. All right, so activate the Trim tool by, again, clicking your right mouse button and then moving diagonally downwards, and delete this partitioning line and then select OK. All right, now we need to cut this profile all the way through both directions. So press S on your keyboard, extrude cut. Set the end condition to through both directions by right-clicking your mouse, and then select OK. All right, so that creates the slot feature at the bottom. Now we need to work on creating this counterbore feature, and again, there are two ways to do that. We can either draw circles here, a circle here at the top face, and then use the standard extrude cut tool to create the opening. Or what we could do more simply is to use the revolve cut tool. And for that, we just very simply need to sketch out half of the profile for this opening, and then using the revolve cut tool to create the overall 3D feature, right? So that's what we're going to do. Let's go ahead and select Front Plane, Sketch, select Line, and from the top here, the center point here, let's go ahead and draw the profile all the way to the bottom right here. And close off the figure. Activate the Smart Dimension tool, and we can see here that the diameter of this hole here at the top should be 15, so half of it is 7.5. So the length of this edge should be 7.5 millimeters. And the distance between this edge and this edge should be 6 millimeters. Again, this is according to the figure here. We can see that the diameter of this hole should be 12, half of it is 6, right? And the length of this edge should be 25. By default, so we set to 25. And this hole, again, goes all the way through to the slot, and this should be 25 as well. And we can see here that's 25 as well. All right, so now just press S on your keyboard. Or in fact, we don't have the Revolve Cut tool feature installed, so go to Features, Revolve Cut. And here's going to ask you for the axis revolution, so go ahead, select this vertical line, and we have a preview for the cut operation, and then select OK. All right, so that creates the counterbore feature. So again, you can see that if we activate the section view, you can see that we have all the necessary features within the component. All right. Now, since we've fully modeled the part, we now need to define the material that is used. And here we can see that we need to assign a material of ASI 1020 steel. So very simply, just right-click, Edit Material. and then select ASI 1020, apply, close. All right. Let's go ahead and delete this image. We don't need it anymore. To find out the mass of this part, very simply just select evaluate, mass properties, and we can see here we have a final answer of 538.6 grams. So the final answer is 538.6 grams. If you want to round things up, it will be 539 grams. Now this makes sense. This value here makes sense. This is a relatively small component. The overall height is about 6 centimeters, and it's about 7 centimeters at its widest section. So it's relatively small, but again, we have steel. We're using steel here, and the density is pretty large. So it makes sense that's about half a kilo, right? So let's go ahead and close this. Okay, so that concludes exercise number 40. If you all enjoyed this video, please don't forget to like and subscribe. I'd love to hear your comments, so please write your comments down below. I hope to see you all in exercise number 41. Until we meet again, bye-bye.